Hi everyone, this video is on exercise 9J question 14. So we have an inverted conical funnel and that's full of salt. The salt is allowed to live by a small hole in the vertex and it lives at a constant rate of 6 meters cubed per second. Okay, then we have the angle of the cone between the slanting edge and the vertical, which is 30 degrees. And we want to first show that the volume of the salt is 1 over 9 pi h cubed, where h is the height of the salt at time t seconds. Okay, so the question may sound very complicated, but we can easily simplify that by drawing a simple diagram. So first of all, we have an inverted conical funnel. Let's try to draw an inverted cone. So it's going to be something like this. And now remember that what we have here is actually about the angle that is between the slanting edge and the vertical. So what this means is basically, if you were to say, let's say here is the center of the circle that you have, and if you were to draw the height from that to the vertex, because remember we are talking about the height that comes from the center of the circle to the vertex of the cone. So this is called h. This is basically the vertical height, obviously. So we show this by h. And at the same time, it's saying that the angle between the height and the slanting edge is 30 degrees. So this is the slanting edge. Basically, it's talking about here. So it's effectively talking about this angle that is 30 degrees between these two. And that's going to be crucial for us. Also, since it's a circle, we can say that this is the radius, right? This is the radius of the circle, because it's going to be important for us in the question. Okay, so now the diagram is complete. Now we want to show that the volume of the salt is 1 over 9 pi h cubed. First of all, remember that the volume of a cone can be found by using the formula of v is equal to a third times pi r squared h. So this is the volume of a cone. And now that we know the formula, because this is going to be useful for us. But before that, there is something that we need to consider. So since we want to find a volume, we need to have all these elements in the formula. Because remember that ultimately we want to show that the volume is 1 over 9 pi h cubed. So it's fine to have pi and h cubed in our formula for the volume. But as you can see, there is no mention of r, which is the radius. So what this means is that we need to find basically the value for the radius and then substitute that into the formula. And that ultimately is going to give us 1 over 9 pi h cubed. So how can we find r? Basically, the point of giving us the angle 30 is basically all about finding the value of r. Because we can just use a simple trigonometry to find r. We can use tan 30, and that's equal to opposite divided by adjacent, which is r divided by h. And now we can rearrange this to have r is equal to tan 30 times h, and we know that tan 30 is equal to 1 over root 3. So we are going to have r is equal to h over root 3. Okay, now we have this. We can also do something else. So it's the time for substitution into the formula of v. V is equal to a third times pi times r squared. So r is h over root 3 squared times h. And we are going to have 1 over 3 pi times h squared over 3 times h again. And finally, it's going to be equal to 1 over 9 pi h cubed. And this is exactly what we wanted to show for the volume. All right, now that we have the volume, the rest of the question is going to be easier. So we want to show that the rate of change of the height of the salt in the funnel is inversely proportional to h squared. Okay, so in order to find the rate of change of the height, all we need to find is basically dh by dt. That's what we want to find, right? Because h is the height and we want to find the rate of change of that. So if you want to find dh by dt, again, it's just a chain rule question for this part. So in order to find dh by dt, we need to again have three different parameters. In this case, we have h, we have t, and the third one is going to be the volume, right? The volume of the cone. So that's going to be the connector, the variable that connects h and t in our chain rule. So we are going to have, because we want to have dh in the numerator, dh by dv times dv by dt, because the two dv's are going to cancel out and we'll get dh by dt. Okay, but before solving this, there is something that we need to remember, and that goes back to the second line in this question, which says the salt is allowed to live by a small hole in the vertex. It lives at a constant rate of 6 centimeters cubed per second. So it's basically telling us that dv by dt is equal to -6, because that's the rate of change of the volume, and it's decreasing because it's outflow. So that's why we have -6, and dv by dt is going to be useful in this formula, as you can see. And the next thing that we should find here is dh by dv, but this one is, we can easily find that because we have the formula of v. So let's find dv by dh, and then we find the reciprocal for this formula. So by using this formula, dv by dh is equal to 1/3 pi h squared. Now that we have dv by dh, obviously dh by dv is just the reciprocal of that. So dh by dt is equal to the reciprocal of this, which is going to be 3/pi h squared times, and we found dv by dt from the question that is just -6. So it's going to be -18/pi h squared. And we can conclude that the rate of change of the height is inversely proportional to h squared. Because remember that -18/pi is just a constant, and then we have 1/h squared, which is exactly the typical format of inverse proportionality. A constant over the variable. So yeah, that's basically the answer. Even they ask us to write down the differential equation relating h and t. So they were basically saying use dh by dt. And yeah, so this is the final answer. That's it for this video, and thank you for watching.